uh, per kg, right? So like that, we can write the unit of a physical quantity also. And this is what is called a universal gravitational constant. It is a constant, but it has a dimension. That is why these constants are called a dimensional constants. If anybody asks me any more dimensional constants, you can say Boltzmann's constant, you can say the universal gas constant, you can say Planck's constants, you can say the same, you can say these are all constants. So in terms of dimensions, we can categorize physical quantities. The large but quantity of physical quantities can be divided into four categories. One is dimensional constant that we have discussed. Other is dimensional variables. Dimensional variable means all those variables. Means area is a is a variable, a variable physical quantity. Volume is a variable physical quantity because any value it can have. A small body and a large body you take, small body has a small volume and a big body has a big volume. So different bodies are having different volume. So volume is a variable. Am I correct? That means volume is a variable physical quantity. All those variable physical quantities having dimensions are called dimensional variables. So area, volume, density, speed, velocity, acceleration, momentum, torque, etc., are variable physical quantities which have dimensions. These dimensional variables they are called, right? This dimensionless constant. Dimensionless constants means all the numerals in the number system, 1, 2, 3, etc., they are constants. They don't have any dimensions. Even they have no dimensions, they don't have any unit also. Those quantities having no dimensions, that has no unit also, right? Right? For example, that I will tell you just now. Next is dimensionless constant, dimensionless constants. One more is there. That is what's pi. Pi is there. Pi is a very famous ingredient of all calculations. Most of the calculations, because when you have to calculate the area of a circle, that is equal to pi r square. Pi is a constant there. That pi has no dimension. It has no unit also. That is a dimensionless constant. So what are dimensionless constants? All the numerals, 1, 2, 3, etc., has no dimension. Hence, they don't have any unit also. Pi, pi. Pi is a dimensionless constant. Next is dimensionless variables. Dimensionless variables means the fourth condition we are coming to. Dimensionless variables. Number one is angle is there, right? It's a variable. Angle means any angle. There can be 30 angle, 30 angle of 30 degree, angle of 45 degree, angle of 60 degree, anything. So as the angle has a variety of values, it is said to be a variable, right? Angle is equal angle. How it is? This is an angle, right? Angle. This is an arc of length L, and this is radius, right? And these two radii is. This is part of a circle, right? These are two radii, makes an angle between these two. This point is A and this point is B. Between these 2 points, we get an angle subtended. This is called angle. But everybody knows that angle is equal arc by radius. Angle theta is equal, arc is L only, divided by radius is. So length is a length, radius is also a length only. Therefore, length is a meter and radius also a meter. Meter cancels. No unit. L by L is equal to 1. Therefore, no dimension. Right? If you're asked to write the dimensions of angle, then we can write like this. I'm telling you now. Therefore, dimensional equation of theta is equal to m raised to 0, L raised to 0, T raised to 0. You can write. No problem. Right? That any quantity raised to 0. 1. 1 into 1 into 1 is equal to 1 only. Here also 1 only. Length, arc is a length, divided by radius also length. Length of the length is equal to 1 only. Those quantities having no dimension, that may be a ratio, pure ratio. Pure ratios are having no dimensions at all. So theta is also a pure ratio. Why it is a pure ratio? Because it is a ratio to similar quantities. Which is similar quantities? Length and radius. Radius and length both are length only. Therefore, if you are asked to write what is the dimensions exactly in terms of dimensional formula, you write theta. Theta is equal to m raised to 0, L raised to 0, T raised to 0, you can write. Because it has no, now it is 0 in mass, 0 in length, and also 0 in time. So this, the value of this is equal to 1. Remember, keep in your mind. Am I correct? So the other one is, other dimensional variable is dimensionless variable. Dimensionless variable is strain. Strain is another physical quantity that you had to come across when we study elasticity. One lesson called elasticity, when we study, you have to come across this physical quantity, strain. Strain is equal to change in length by original length. Suppose a wire is hanging from a rigid support. A thin wire is hanging from a rigid support, and it is attached to a big weight here. So this much was the original length of the wire, right? By the application of this weight, the length is extended by another small value L. Am I correct? So the wire has a length. Original length is equal to capital L. You can see. Now, by the application of a weight at the other end, the free end, it is extended by a small value, a small L, right? Now, the ratio of this small L divided by capital L is what you call strain. Change in length by original length is what is called a strain. So strain we can write as equal to, strain is equal to change in length, the capital L divided by capital divided this is smaller. Both are having the same unit, therefore unit is cancelled, no unit is quantity has. When the quantity has no unit, that cannot have any dimension also, because L is written L only divided by this small L also, length, the unit of length and dimension. When we apply, every length is applied in terms of capital only. Capital cancel is equal to 1, right? Now we are asked to write what is the dimension. Write the dimensions of strain. Then what you will do? You will write m raised to 0, l raised to 0, t raised to 0. That is equal to 1. I can write. This is another one. Next is specific gravity. Specific gravity is also called as a relative density. Remember that? That means density of any substance compared with the density of water is what is called a specific gravity. Or sometimes it is called relative density. In relation with the water, how many times the density of the particular object is. That is what is called relative density. So relative density is the ratio of two physical quantities. Both are densities only. When two quantities, the ratio of that both are same quantities, that is called a pure ratio. Pure ratio doesn't have any dimension or any unit. So specific gravity has no unit. Or specific gravity is also called as what is called a relative density, that has no unit, right? That is specific gravity or relative density. I'm writing relative density. Relative density means density divided by density. Density divided by density, right? Density is equal to m by L cube divided by m by L cube, right? Mass per volume, right? Mass per volume is called what is called this density cancels, that is equal to 1 you will get. So this relative density of specific gravity is also a dimensionless variable, right? These are the things about dimensions. So dimensions are very important. So using dimensions, we can know or we can obtain the unit of a physical quantity. Any physical quantity dimension, right? From the dimensions, accordingly as the physical quantity is involved in the SS system, you go on writing the units separately, then you will get the unit of that of physical quantity as a whole, right? This is the condition. For example, force is equal to mass into acceleration. Mass is having a unit is equal to kg, and acceleration means what? Displacement over time square, L by t square. That means meter per second square. So kg meter per second square. Kg meter per second square is given by another name in physics for force is called Newton. Newton is equal to kg meter per second square. So kg meter per second square is the unit of force. The unit of force is obtained by multiplying the unit of mass into the unit of acceleration, right? From the dimensional formula also, we can obtain the unit of the physical quantity force. That is the great help we have from a dimensional analysis. So any quantity, the dimension can be obtained. So to write the dimensions of any physical quantity, what you must have, you must know about the physical quantity. One more example I will give you, that power. Power is equal to work done divided by time. Work done, that is equal to force into displacement. Force into displacement divided by force is mL t raised to minus 2. Into displacement is equal to L. Divided by time is equal to capital T. Capital T. Everything means 1 by t means t raised to minus 3 it will be, right? L and L is L square. You are getting this as equal, power is equal to mL square t raised to minus 3. Power you are getting. So to know how to write the dimension of a physical quantity, at least you must have an idea about that. What is power? Power is the rate of work done by a body. The rate of work done by a body, or rate of energy utilized by a body, by a device, is what is called the power, right? W by T. So F into S divided by T, mL square. mL t raised to minus 2 is force. Force into S means displacement. Displacement is L only, divided by T. You are getting mL square t raised to minus 3. Any physical quantity, this the unit of the dimension can be written. But this one also we can write kg meter square per second raised to 3. That means second raised. So this is given by another unit called watt. Actually, watt is well this only, kg meter square per second raised to 3. Or second raised to minus 3. That is called by a new name. To speak out all these things, kg, meter square, per second cube, etc. To speak it is difficult. That is why we make another beautiful word called watt. Watt is the unit of power. So from the situation, from the dimensional formula, we can write a unit. Certain physical quantities are having a new name applied to those. Just like this power has a new name, Newton has a new name, and also work done also has a new name. That is called joule. Joule. Am I correct? So in kg and meter and decimal also we can speak. That is same as equal to joule. So certain physical quantities always very frequently involved in physics. Those physical quantities are having new names given for convenience. That's all, nothing else. Right? So this is about dimension. Today, when you go through the notes that I have already sent it to you, and also go have a what you call reference textbook and find as many as physical quantities and try to do the questions. That means how the dimensions of that physical quantity can be written. So for that, you must know about the physical. Clearly in the book it is given what is that physical, how the physical quantity is obtained. The formula of the physical quantity you must know. From the formula we can easily apply the dimensional formula of those. Now there are so many advantages of the dimensions. Dimensions can be used for conversion of one system into another system. For example, a unit is in the SI system, the value of a physical quantity is in the SI system. We have to convert into CG system very easy using dimensions. Next, we can check the correctness of an equation. Any physical possible equations can be checked where it is correct or not. Then derivation of the formula. A formula also can be derived using dimensions. These are the things we have to learn in dimension analysis. That part I will teach you tomorrow, right? So use a what is called reference copy also and find as many as physical quantities and write the dimensions. Thank you very much.